All right, so this tutorial will be about creating the face, and we start with the eyes. So we open our Bear tool, and there is a human face guide collection available, which we will create. So after creation, you will find this collection here. So the collection contains several guide components, including the eyes. And if we go to build, activate guide, and choose selected components, it will create the guide nodes for the selection. So we can select the entire collection and hit build. But since this tutorial is only about the eyes component, we'll go step by step and select only the eyes and hit build. So this will take a few seconds. And here we go. So keep in mind that the eyes guide has been created with the default settings, which you can open using the settings button here. So we will adjust these settings accordingly. Um, and there's actually only one setting that needs adjustment, which is the lid joint count. But let's take a look at this in a second. So let's first see what has been created. I will hide everything else so we get a nice idea about how our eye component looks like. So these are the guide nodes for the eyes component. And if we open this group, we will also see all the guide nodes. And yeah, you can see here that there's the upper lid, the lower lid, and also outer lid lines. So these are the default locations. And you need to keep in mind that these locations need to be respected, and also the orientations need to be respected. So you should not go ahead and kind of twist these nodes. Let me just go to object mode. So this is the correct location or orientation for these pivot nodes, for these pivot guide nodes. Yeah, so these should be maintained and not like twisted around or something like that. We can of course align them a little bit like this, right? But yeah, more about that in a second when we actually align the guide. So let's first move our component in place. So if we unhide the geometry and select the guide again, um, we should match the global scale roughly to our character. So if we do that, keep in mind that when you change the global scale value here, you need to rebuild the guide, and that will reset the global scale to 1. So we always want to work with global scale 1. So whenever you scale this, you do a rebuild here of the selected guide component, and that's it. But in this case, we don't need to do it since the default scaling already works quite well for this character. So we only place it roughly to the eye location. So this will help us for placing each individual guide node. So let's go ahead step by step, and we start with the pupil and ball location nodes. So the ball guide node needs to be aligned to the center of the eyeball sphere geometry. So we can simply go ahead and align this node using the match transformations. So we just do match translation. And this is we just need to make sure that the geometry of the sphere obviously is centered correctly. So this needs to be made sure at modeling stage. Um, so this will help with the alignment, of course. We can also do temporary pivots and then align to that, or yeah. use different methods, but yeah, obviously it needs to be centered to the sphere correctly. And then the pupil we can snap to the uh, center vertex of the geometry. So this vertex here. So we will select the pupil guide node and activate the point snapping, snap to points. And here we go. So as you see here, let me just hide the geometry again to make it clear. So this node, this node is always pointing to the pupil. So this will align the controls correctly in terms of orientation. So we don't need to bother about the orientation of the ball, which is actually locked, since this is aiming to the pupil. So once that is done, we can actually go to the shape node of this guide, and we can easily select it by opening the bare builder underbuild in the guide tools, select shape, and this shape we can move forward, so it's easy selectable. So this will be the FK control for the eyeball. And what we should do here is rotate this by 90 degrees and align the scaling to the iris. For this one, we want to go to the front view and scale this to the iris size. So this is important to scale, matching to the iris size for the iris component to function correctly. And yeah, we can just place it wherever it's convenient for the animator to select. So this should be pretty much fine. And yeah, then we can go ahead with the eyelid nodes. And it's most convenient to use the point snapping again. So we snap this one to the corner. And first of all, it's important to define the eyelid topology and the corner loops. So this should be defined at modeling stage. So let's say this is the corner loop here, the inner corner loop, and this is the outer corner loop, right? And the upper and lower loop count should be the same. So let's first check if our model is actually correctly set. So we select the upper edge loop here. And actually, let me go to gray shaded. This makes it much easier. And let me open the poly count settings, the heads up display. And these are 17 selected edges. And the lower one is also 17. So that's absolutely perfect. So we can snap the, let me bring back the eye guides again. So we can snap the inner lid guide pivot to this vertex here. So we already did that. And we will do the same for the outer one. Make sure to snap it to the same loop. And also snap these ones. And for these ones, we can actually snap to since these are Bezier handles, we can snap them to roughly to somewhere here, and we will do finer adjustments in a second. So we'll just do this very roughly here. So the goal is to match this curve here as precisely as possible to the eyelet. Now you might say, hey, why do we not use the loop selection in the model, the edge loop selection, and create the guide from there? Yes, technically, of course, it would be possible to implement a method like that. And it wouldn't be a big deal. But personally, I prefer um, greater control by aligning this manually to make very fine adjustments on how the guide is placed. But as a starting point, it might be a good idea to implement something like that to the bare tools, actually. So there could be something like that in the guiding. I might add a feature, such a utility in the future. But we're going to make use of the bare guiding tools for the eyes in a second. So first, we're going to align this as closely as possible and make sure that you keep the orientation right. I mean, you can adjust the orientation here a bit to align it, perpendicular to the to the shape flow. But make sure that the y-axis is always keeps pointing outwards, and the same for the lower ones. The y-axis needs to point outwards. So the goal here is to have the eyelet, to have the guide curve here matching the eyelet border as closely as possible. Almost so it is being hidden by the geometry. So it will kind of disappear here. This would be the perfect match. So we do some smaller adjustments here, and then we are pretty much good to go. Can also adjust this a little bit, bring them a little bit more inwards or outwards inside the flesh. So we actually want to make sure that this line is pretty much hidden by the geometry. So we don't get any gaps on closing, although there will be a automatic closing feature which perfectly makes the vertices align to each other. But we always want to make sure to work as precisely as possible anyway. Let me actually deactivate the geometry selection here, which makes it easier to select the guides only. Right, so once we are done with that, we can select all these guides, including the inner lid, so all of these, and go back to our bare guide tools and hit select shape. And we will bring these guys out a little bit and change the shape to whatever you like. I would say sphere, possibly, or could actually remain to be a circle, but then you want to do a 90-degree. yeah, this will be the location of our controls. We can also use for these ones, for the main upper and lower controls, we can use arrow circles, for instance, scale them up a little bit, and maybe make these ones slightly smaller so they differentiate from the corner controls. So this would be a good control layout. All right, let's save our setup and go ahead with the outer controls. So it's the same story here. But first of all, we want to make sure we want to choose a outer loop. And I think the outer loop should be this one here. So we keep that as a reference. And we can also use the point snapping here. So here, this is the corresponding node group for the outer lines. So here, this is the inner lines, and here, this is the outer lines. So let's snap them very roughly. Snap the outer one here. And then deactivate the point snap again and do our manual fine adjustment. It's also helpful to use the outliner. Might be easier to select at times. Yeah, and with this we should be good to go. Select the shape again and bring them out a little bit so they're easily selectable, and maybe for these ones we choose the sphere and make them smaller. And this should be good enough for the outer lines. Actually, we can also move these shapes a little bit so they are just easier selectable and are placed a bit further away from the main eyelet controls. So we can move them very freely. This is just for the control shape location. Again, this is different from the guide pivot. We have the guide shape and the guide pivot. So the guide pivot defines the location of the controls, while the guide shape defines the appearance of the controls. It's always a good reminder on how the guiding system in Bear works. So, and we're already pretty much good to go with the guiding, with the eyelet or eye guide. Now, one thing to notice is that we still want to adjust the loop count. So we counted 17 edges, which makes it 18 vertices. So we go to settings and type in 18 for upper and lower. So upper joint count equals to vertex loop count. And the rest can be pretty much standard, unless you want to also create iris squash and scratch, perhaps in the highlight, or the squash and stretch, we actually want to create that, yes. But there will be no guide for it because the iris squash and the iris is guided already the uh, by the pupil and ball guide and the size of this iris control, iris guide shape, and the overall squash and stretch, which will stretch which will give lattice controls for the overall eye, is also calculated or guided sphere, by the sphere geometry. And this one actually we want to flag here in the eye guide settings. And we will do so by pasting the name of the cornea here. Right here in the squash and stretch. So we have L and R. And the eyeball left geo, these are several geos, so all the geometries that make up the eye. Those geometries will then receive the squash and stretch lattice. So if we deactivate this, we actually don't need to plug any geometries in here. But if we activate this option, we wanna we wanna put all these geometries inside here. So we do this, we do that, and we separate by a comma, and we also add the body geometry. Same for the right geo. And I think that's pretty much all about it. Okay, let me just hit save. And yeah, let's just do the eye guide rebuild to represent all these setting changes that we made. The rest of the settings should be fine. We have the control suffix here and the default space nodes. That's all very much fine. So we should be good to go with that. Actually, worth to mention is the pupil size. I just accidentally changed this. So the default is 0.5. So this defines the ratio between pupil and iris. And the ratio between pupils and iris is actually, I think it should be 0.5. We can find out by scaling this control here or a temporary node, any shape. Scaling this temporary. So we have 3.6 here. And if we scale it down to match the pupil, it will be like 1.8. So it is about half of it, right? So this should be pretty good. 0.5 is a correct initial pupil size relative to the iris. So if we have a bigger iris, by default, it should be a higher value. And if we have a smaller pupil, it will be a lower value. So this ratio needs to be manually detected. And we also want to activate has joint guides. This should actually be activated by default, as you pretty much always want to have one joint per loop. And this will create the guides for the joints for them. So if we rebuild the guide now, it will the guide nodes will be updated with the new settings. Right, so here we have the rebuilt guide with the joint guides in place. So taking a look at the joint guides, we will see they are not aligned to the loops yet. I will actually add a functionality to flag the vertex loop here, but this option isn't yet functional. So what we need to do for now is use the bare tools to align the joints to the edge loops. So if we look at the joint guide nodes, we can see in the channel box that there's a curve position value. So this defines the position of the uh, guide on the curve. And there's a tool to match these curve positions to the edge loops automatically. You can find them in the guiding section of the bare tools. And if we make this a little bit larger, here it is. It is called Align Curve Joints to Loop. And if we take a look at the tooltips, we just activate them real quick. So whenever you need help, activate the tooltips and reopen the tools. And here there's a tooltip right here, and it says for the align curve joints to loop button, it says align the selected curve joints group selection to a selected edge loop. Select the edge loop first and add the curve to the selection. So that means we select the edges and then add the curve to the selection, and we can find the curve under setup. It's this one. So what we do is we go into edge poly mode, and we select the upper loop, this one right here, and then we add this guide curve to the selection and hit align curve joints to loop. So this has aligned the joint guide nodes now to the edge loops. Only we need to make sure that it's the right direction. So it should start with the first guide node at the inner corner and then end with the outer corner. So what we need to do is I just go undo for getting the selection again, and then hit the reverse direction option. This function is a little bit slow for now. I will actually speed it up significantly in the future. There could also be a more sophisticated guide setting. Actually, it will be handled with the this flag here in the future entirely, so we don't need to worry about any of that right now anymore in the future. So now they are in the right direction, and we do the same for the lower lid and for the outer lids. So we select this edge loop, then go to lower lid, set up curve. I'm not sure if it reverse direction needs to be flagged. Let's try it out. Yeah, actually it's correct. All the joint guidance are aligned correctly. And actually for the outer lines, we don't need to have as much precision, and they're already, I mean, we can do it, but it will not make such a big difference. We need very fine precision for the inner lids, but for the outer lids, it's actually good enough. We don't need to align the joints. So that's pretty much it for the eyelid guide. Now we will create the rig and then go ahead with the skinning. So let me just go to build and activate rig, selected components build. And I did make a mistake. Actually, these values should have been put into this section here, into this section. It needs to be reversed actually. That's my bad. So to do this most conveniently, we can go to the extra attributes and cut and paste the attribute values accordingly. So this value needs to live here, and this needs to live here, and this one needs to live there. It also says geos in plural. So just for explanation again, the squash and stretch geos will receive the lattice deformer. So this needs to be multiple geos, all the geos that are in this area. And this value is only used for calculating the iris rig, for getting the radius and such, and also for getting the size of the squash and stretch. So let's try that again. Rig selected component. Here we go. And here's your iRig. So let's do a very first rough skinning for the eyeball, at least first, to showcase. So we can go to the selection group and find the eyeball skin joint for the left side. Select the geometry, apply skin cluster. Do the same for the right side. And here is your aim rig. And in the next video, we will go through the eyelid skinning. Thanks for watching. See you in the next video.